we're going to integrate what we know about updating the database through business components and add some more advanced concepts. For this, we're going to focus on a KB that we're developing for a healthcare service that offers its patients the possibility to see doctors in one of 3 shifts: morning, intermediate, or evening. To represent these shifts, we have the shift transaction that's dynamic. We turned on the data provider property and said that it was to retrieve data and only to retrieve them because we've set it as read-only. Here we indicate 3 shifts. In addition, we have the patient transaction to record the patients, office to record the offices in which these doctors' visits will take place, and physician to record the information of each doctor. Doctors have one and only one medical specialty. Finally, and we're going to focus on this one, the office visit transaction that records each office visit in which a doctor sees a list of patients on a date and shift, morning, intermediate, or evening. Since patients are to be assigned a number to receive care, an attribute is added on the first level to record the last number given so that a serial rule can be used each time a new patient is entered through the transaction. It's also necessary to indicate the office where the visit will take place. We can already note that although we've defined that the trio composed of office visit date, physician, and shift cannot be repeated because it's the primary key, neither should the office visit date, shift, and office be repeated. That is, there cannot be 2 office visits on the same date, shift, and office. Therefore, these 3 attributes form a candidate key, and we create a unique index to represent it and secure it. In addition, we'll want to add 2 business rules. The same physician can see patients in up to 2 shifts on the same day, but not 3. On the other hand, it should not be possible to enter a patient who already has an office visit scheduled with a doctor of the same specialty. We check them in this way. Here we're calling this procedure only if in insert mode. It counts the number of office visits of the physician on the date we want to assign a new appointment, and will trigger an error if it returns 2 or more. Here we have the serial rule so that when a new patient is being entered for the office visit, the next number to see the doctor is assigned. And here we disable the field because we don't want the user to modify it. We're calling another procedure that checks if the patient has a pending office visit for the same specialty as the office visit for which we're trying to schedule them. In that case, an error is triggered. We can see that the procedures and the error rules are only executed when we try to insert the header for one case and a line for the other. Also, note that since we've applied the work with pattern to the transaction, it has automatically added these rules. Among them, the parm rule to receive the key and mode. Our objective will be to review and explore in depth what, of all this, is executed when the operations are made through the business component. Let's assume we have this data in the database for next week, with no patients scheduled yet, except for Thursday, which has patient 2. Here we see them in the work with. We'll want to insert a new office visit for Monday and test that it works as expected in all cases. Let's summarize everything we know that the running transaction will check when trying to insert data, and then we'll see what the business component checks. Because of the order of the attributes in the transaction structure, the order of the checks will be as shown. We have not added the data type checks. For example, for the first field, it'll clearly check that the date is valid. The next check will ensure that there's a physician with that ID in the physician table. Otherwise, this referential integrity error will be displayed. Let's enter physician 2. The next thing to do is to invoke the procedure that counts the number of office visits that physician already has on that day. And if it gives 2 or more, the error rule will be triggered, which shows this message on the screen. With physician 2, we did not get an error, but if we enter physician 1, who we already know has 2 shifts that day, we do see the error. This internal error code corresponds to the second parameter of the error rule. If we don't set it, the error ID will remain empty, which does not affect the operation at all. Let's insert physician 2 again to continue. The next step is to check referential integrity with shift ID. Now, let's assign shift 1 morning. At this point, the uniqueness of the record we're trying to insert is checked. In this case, it did not find that the record already existed, so we don't see anything. It'll then check that the office exists. For example, we type 25, and now this one, which does exist. If we had tried to enter a record that already existed, for example, note that for this physician and this shift, we already have an office visit scheduled for Wednesday. So let's see what would happen if we change the date for the new office visit that we want to assign, and we place this one for Wednesday. It's not showing it interactively, but if we click on confirm, the message record already exists will be displayed. Let's place Monday's date again. When leaving the Office ID field, it'll already be possible to check the candidate key. In this case, we'd entered Office 3, but let's see what would happen if we entered Office 2, which we know is already in use by Physician 1. This error message is shown. To check it, the unique index is used. Once again, let's enter Office 3, which we know is not being used. This is the end of the first level checks. Now we check each line of the second level. If we enter a non-existent patient ID, the referential integrity will fail. Let's enter an existing one, number 1. Then, the uniqueness of the primary key of this second level will be checked. Since no other patients are entered, it will not fail. But let's try another line. Let's enter number 1 again. Here we see that the uniqueness is indeed being checked. So let's enter another patient, patient 2. The error rule we had stated is being triggered. Why? Because patient 2 was already scheduled for Thursday's office visit with physician 1, of the same specialty as physician 2, family medicine. Therefore, we cannot schedule this patient. If we now press confirm, we'll see that the office visit has been entered. Now let's try to repeat the same thing, but inserting through the business component. So let's delete the office visit we've just entered and try again. To make it really easy, we've created a web panel with 5 input variables, for the 4 relevant attributes of the office visit header, and for entering a patient. First, we'll try to insert through the BC. For this, of course, we've enabled the business component property of the transaction. From there, we were able to create this variable of the business component data type, through which we'll insert data. As a good practice, we first ask for new memory space for the variable to make sure it's clean. We assign values to the 4 elements of the header from the variables on the screen. Next, if the field on the screen for patient ID was not left empty, then we'll try to add a patient. we have this variable of the data type of each line. We clean it with new, assign a value only to the patient ID element, and add it to the patient collection of the business component. In this way, we've loaded the structure of the office visit variable. Now we have to give the order to try the insertion, and if it's successful, commit. In the messages variable of the SDT data type that comes predefined in the Genexus module, we get all the messages that have resulted from running the insert method. And we insert it on the screen to view all those messages. Then let's run to repeat everything we did through the transaction, but now in this way. Let's choose Monday, the date we wanted. Also, let's place a non-existent physician, a non-existent shift, a non-existent office, and even a non-existent patient to see all the messages that will be displayed when we try to insert data. We see all the referential integrity errors. Patient didn't even get there, because that would only happen if the header could be inserted. Now let's place physician 1 on shift 3 in office 3 with no patient. We know that it must fail because of the error rule. Note that the error message ID is the one we placed in the rule. We can break more checks, and we'll see it in the message collection. For example, let's enter the shift 25, which does not exist, and the 2 error messages are displayed. Now let's try the primary key uniqueness check. Let's try inserting a record for Wednesday, physician 2, shift 1, office 3. Alright, that's what we expected. Now let's try inserting the office visit for Monday on shift 1, but for an office that's already being used, that is 2. Note that the uniqueness of the candidate key has been checked. Now let's insert the correct office. If we leave patient ID empty, the header will be inserted successfully. The message is of warning type, and it's the one displayed in the transaction when the pattern is not applied to it. That is, when it does not return to the caller object. Let's delete the record and try again, this time with a patient. We enter a non-existent patient, and the referential integrity error is shown. So the header is not entered. If we now try to enter patient 2, who already has a pending office visit for the same specialty, the error is also triggered and it doesn't save either. Now let's enter patient 1. Success! If we look at how this office visit was saved, it looks exactly the same as when we inserted it through the transaction. Note that the serial rule was also triggered, giving the number 1 to the patient and updating the attribute of the last number given. Of all the transaction rules, which ones were triggered when inserting through the business component? As we already know, all those that do not depend on the interface and do not make sense in this context are triggered, such as the parm rule, logically, because the business component is not an object that can be invoked like the transaction, but a special data type with special methods. In this case, the parm rule was not only not triggered because it does not make sense, but also because the entire block of rules added by the pattern were qualified with this, which is known as an environment attribute. It indicates that these rules are only included when the web transaction is being executed, and not when it's executed as a business component. If, on the other hand, we wanted some rule to be executed only in the context of the business component, then we can qualify it like this. The brackets are needed if several rules are qualified and not just one. For example, let's suppose that when inserting through the business component, we do not want to prevent a patient with a pending office visit from being entered. We only want to throw a message in that case. Then, we qualify the error rule to be executed only in the web environment, and we add a message rule for the case of the business component. Let's try it. If we try through the transaction, an error is shown as we expected. If, on the other hand, we try through the business component, the message type is a warning and is inserted without any problem. Let's leave it as it was. Events can also be qualified. Of all the events defined in a transaction, which are executed when the business component is used? Only the start and after TRN. If these events include references to objects with a user interface, these references are ignored. Coincidentally, these are the two events that the pattern added here. But let's note that they're not qualified as such. That is, they'll only be executed in the context of the web transaction, and not when the business component is executed. If we wanted to define other options for those events that are valid only for the business component, then we would write them between BC square brackets, either by encompassing them or within each one, distinguishing what is web from what is BC. Let's go back to the insertion with BC. We may want to do the same validations that the insert will do, but without updating the database. For this, we have the check method. We invoke it, and then check the result of the operation through the success method, which will give true if it was successful and false otherwise. Let's stop here for a moment. The result of applying this method to a BC will refer to the result of the last operation performed on the BC. Here, it's check, but it could have been load, or delete, or save, or even insert or update, or insert or update. In particular, these last methods already return their result, so we don't need the success method to know it. Therefore, we perform the operation and ask for its result in the same statement. Although it's not essential, we also have the opposite method, fail. A message will inform the user whether the check was successful or not. To test it, let's comment the database update. We run it. The last office visit date scheduled is this one. Let's try to check an entry for the next day. We enter a non-existent physician, non-existent shift, non-existent office. The error and fail messages are shown. Now let's enter everything correctly for the first level and a non-existent patient. The error and fail messages are displayed. With patient 1, we know that the error rule has to be triggered. What if now we choose a correct one? The success message is shown. Logically, nothing was entered in the database. Let's leave everything as it was. So far, we've seen that regarding the checks and execution of business rules and events, there's almost no difference between entering a header and its lines through the transaction and doing so through the business component. We also reviewed how to work with the business component, and, in particular, we added lines with the add method of the collection. Then we'll review another one with the data provider. One note. Here we test the operation of the business component manually, through a web panel that we specially built and tested at runtime. But the way to test this so that it can always be tested again after any changes or even integration is with unit tests. It is not advisable to do manual tests like the ones we did here. In the next video, we'll change an office visit, not insert it. Changing it involves changing data in the header and also in the lines, inserting new ones, modifying existing ones, and deleting others. And we'll see, as we did here, that the rules are triggered. We'll also look at deletion. You could skip that video if you think you've mastered these cases and move on to the next one.